went to this part, I think it was just like this part probably was like kind of problematic. So I would like to add two things in here. If you would like to use that is specific, just like component that I used, and then you would like to download it. So this is the website that you can download the plugins for Grasshopper for Rhino. So this is called Food for Rhino, and then you can find the plugins for Grasshopper. Some of them are like open source, free for everyone. Everyone can use them, and then there is no charge for them. And then some of them are really moderate as for the expense, and then some of them are really expensive. So you can pick whatever you want in here, and then you can go on the page referring to the plugin that you have, and then you need to have a free account and then open up an account. So you can go and then you can say download the version that you want, and then the version that you're working on, depends on if you're having like Rhino 5 or Rhino 6. Sometimes we have like a kind of some of the plugins that they are not working with the older version. So you need to look into the current version and then the version of your Rhino that you're using, and then find the proper one and then download them. And then when you download them, there are two ways of using them. So let me download this for as a kind of example in here. So I think it's going to be very quick. So I'm going to download this. So what you need to do, you need to go to your download folder, and then you're going to open up, and you need to extract the file that you have, and then also unzip it, and then extract it. And it's going to be the same sort of name of the folder, and then you need to go inside and then see that the folder that you have in the property is not read only. So you need to make it just like accessible to the system that you're using. And you need to go to Rhino, and going to Rhino, go to File, to Special Folder, to the Components folder. And in the Components folder, as you can see that I have like these plugins in here. So I already have the pufferfish in here. I don't know what is the version. I think it's an older version, but I'm going to add this just for the purpose of this class, and I'm going to show you what's happening in here. So you can just copy or cut, and then Control C or Control X and then Control V in here, which is like the pasting in here. So you can paste it in here, but don't forget that this is like a kind of I think everyone's mistake. It's not going to work unless that you're going to close off Grasshopper and Rhino, both Grasshopper and Rhino, then reopen it, then it start working. So by doing this, so you're going to have the access to this specific component that I use. Actually, I like it a lot because it's helping me to have like a kind of both side or one side of the offset that we are using. Although that this is also the offset mesh. We don't use offset mesh, although that we have like also this guy, which we have like some type of issue sometimes with this guy, but it's okay, I think, for what we are doing in here. So we have the surface, and then we have the distance. Let's say we have the distance as 0.15, and then sometimes like this guy also has like some issues, I think. So yeah, so now we have this guy, and then this is the two surfaces that we have, and then that is making things a little bit, just like probably complex for you guys, which I recommend you to use this guy rather than having two separate surfaces in here. So one in here, one in here, they're coming, and then we need to join them together. And then for doing this, we have like different sort of, just like method, but sometimes we have like some issues with the surfaces. I highly recommend you to use pufferfish for this exercise that we got in here. So let me show you what's happening. So we have this guy, we have this guy, and then we have this guy. So now everything is coming together in one sort of, piece. So and then I can do the same thing only by using this guy in here. So I think, just like that would be probably a better way of using this. Although for the loft also we have like some other um, also option that we can use. For example, if I'm gonna go and then say loft and then close loft and then okay, then sometimes because of the uh, what is it, the plane for the surface that we're using probably is not going to work. That's the kind of issue that we have. So that's, I would like to have one component instead of these guys. So I'm going to tell you how you're going to do this. So you need to grab this guy, which is on their surface, on their utilities, and then this is the offset surface, and then you need to apply the distance that you want, and to um, complete the task, you need to connect it to the extrusion of the surface that we had at the beginning from the contour lines that we got from the surface. And then this is a loft. This is the same sort of command that we have in Rhino. So we are lofting the first surface that we have as the extrusion by holding shift. So the second surface also, we're gonna have this guy as a second surface. And then all of these guys, this is one surface as the extrusion, this is the second one as the offset, and then this is the sets of the curve that it's going around and then wrapping the two surfaces together as a loft. So we're going to use a, oh, sorry, I think I didn't mention loft before. So it's under surface, under freeform. You have loft in here, so you can use loft in here. And then again, you need to hold shift to connect the second wire. Otherwise, is going to replace the first wire that you got. So let's say this is the first wire. If I'm going to use the second wire, so it's going to replace the second one. So I need to hold shift and then connect this. So now I have one part in here, one in here, and then one in here. So I need to merge them and join them together. So I'm going to use a component. It's called merge. So merge is under set, under tree. So, and then you don't need to be worried about this, but you can zoom in and then you can delete this if you want, but you don't need to delete the fourth one. So still is working, and then it's working perfectly. So the whole thing coming together, so I can bake this and then yes, okay, so everything is good. So if you are worried about some other things like the connection of these guys, so you can try and see if the union that we got in here still is working, because sometimes we have like some jagged sort of just like edges, and then sometimes it's not going to work because of the, again, it's not a bug, it's a kind of issue with the plane that we are using in here. So I can add this guy and see if it's going to work. Well, we have a kind of issue in here. So this is the kind of issue that we got sometimes. Well, many times actually. So, and then I wouldn't recommend to do this right now. So I would like you to bake this if you want to use it. And I think everything is good. So, and probably we can see that if we explode, we ungroup this because it's grouped. Always I use group. So ungroup this and then put them together and then see if it's getting together. No, that's the kind of issue that we have, like some edges that it's not working. So that is, it's not hurting actually your design. So everything is together, is one piece. Don't worry about that. So it's not seeable sort of seam that you have in here, but still you cannot put them together. So that's the kind of issue. Probably that's the reason that I'm using this guy rather than this guy in here. So it's a kind of, just like, there are other ways, there are multiple different ways to do this and to tackle this kind of issue, but it probably is going to be a little bit, just like hard for you guys to do it, and I wouldn't recommend them. So, and by doing this, I think I answered the question regarding this part, and I'm going to delete this baked geometry that I have in here. I'm not going to use this. I'm going to have my surface in here as the surface that I have as a kind of hypothetical surface for my design, and the rest of the I don't know, work is probably would be another surface I can have. I don't need to add any other surface. I think the one surface would be good. So, and any questions so far?
I had a question about applying it to poly surfaces rather than single surfaces. Is it best to just explode it, or is there a way to use an entire
No,
poly surface?
you cannot. You should explode it. You cannot, just like use it as a kind of poly surface. So that would be the best way. Yeah. And
Okay.
then you can add them as a multi surface that we have in here. So right click and then go set multi surfaces in here.
All right. Thank you.
Any other questions?
What's the command to show, like, where it shows, like, the red arrow, it shows where the component is and the ribbon? How do you make that pop up when you select
So
it?
you need to hold Control and Alt and then go on the component and then left click.
Control Alt left click. Thank you.
Yes. And then some of the components is not working for them because they're like a kind of program and a script inside that. All the default component, it works for them, but if you have like Ladybug, for example, or Honeybee, they're not working this system because the programming is different. So, all right, if we're good, actually, let's move to the next part of our work for today. If you have any question, just like before I'm going to start, just like next part, so you can jump in and ask. So we talked about these the series of the four layers of the components, if you remember last time, and then I showed you that it kind of just like a without any sort of coherent sort of style type of diagrammatic understanding about the four specific layers, although we can have more of one of any of these layers. And then, but this is like a kind of typology of the layers. And then we talked about the threshold, and then we talked about the fenestration, and then also the additional skin, and then at the end, the shading and louvering. So we talked about the number 4, and then we're going to do what we're going to go to do actually for today. So it's the one more step in this kind of fenestration, and then we're using fenestration. Also, if we have time for today, so we're going to the next part, which is going to be the additional sort of a skin. So everything as for the typology is going to be covered in here. So this is one step. And then this is the second step. This is mostly more like a perforated sheet. And then we don't use it as a kind of fenestration. It's more of a kind of additional sort of a skin to the building. And it's not being used, typically by the architect and by the designer as the facade, as the major and the main threshold of the building. So we have like this kind of, just like the I would say type of the iteration that with like Tom Main morphosis kind of works, and then Caltrans, and then other project. If you've seen those projects, I don't know if you've seen Caltrans, and also the federal building in San Francisco. So we have this kind of, just like let me see if I can bring it up. Probably it's not going to be that. I don't know. It's if we can have some images of the. So if you see this sort of, just like facade, this is the additional skin that I'm talking about. It's not the same shape, but it's the same sort of analogy that I'm the same typology that I'm using. So you can see this, and then we have like the skin back behind us, and this is like the additional skin. So fenestration is back behind us, and then this is a very nice combination of let me see if I can bring up a better image so everything is just like so low res. So then the secondary skin is infused with the louvering system in here. So I think it's a very good example. So and what we're going to do today, so we're talking about two other typology, and then I think if we have time on Friday, we can spend I don't know if we're gonna have like another session on Friday. Depends on your professors and then Philip. So whatever the level coordinator says. So and then if we're gonna have another session, we can talk about some other stuff too, or we can go to the Q&A for Friday. So then let's just start with this example and then how we're doing this and then how we're working with this. So I'm using a surface in here plus the fenestration as the boxes. If you can imagine that with these are the boxes that they're having a relation to the surfaces as the subtraction, and then the distribution of these guys are in here there are like random distribution, but you can use other way of distribution. So random probably is going to be a little bit more complex. That's why I use random. And then I didn't make this definition too complex because randomness, we have like some sort of overlapping um, of the boxes when we before we subtract them. But I tried to make it very simple, not to get too much of detail of the technical detail of the computational design, to make the distances between the subtraction in a way that they're not overlapping. So if we're going to see some overlap, that's fine. It's intentional. I didn't make it just like too complex actually. So let's just start with the surface that we have in here. So this is the first thing that we need. So we need to bring in the object that we have from Rhino to Grasshopper. So I'm going to hide the surface that I have in Grasshopper. Then I need to see the edge I need to get these edges in here. So I'm going to get the edges for this surface that I have. The reason that I'm getting this because I would like to offset it inside, and I don't want to see the boxes is having like some type of, just like overlap with the corner of the surface that I have. That's why I would like to offset everything inside a kind of a smaller sort of area rather than, just like using the entire surface for this. So I'm using this, and then this component is under surface, and under utilities is called edges from surfaces. Edges from surfaces, and I need to get a point which is inside the surface, and then that way Grasshopper can just like calculate the edges for this guy. So there is a component that is giving me 1 point, and that is point the centroid for the surface that I have. It's under surface, under analysis, under surface, under analysis. You can find it in here. This is called area. So if I get the area for one specific, just like surface in here, then I'm going to get the area, the number, and also I'm going to get the centroid as a point. So I can use this centroid as a point to this guy, and then we're getting, just like the edges in here as the curves that we have. And then if you look at the data list that we have in here, the data list for the edges, so we're getting 4 different lines in here, and then 4 separate lines, which means that we have 1, 2, and 3, and 4. And we can put them together, and we can make this like a kind of one geometry together, but we don't need it for now. I think everything is fine. So what we're gonna do today, for the further reference, if you're interested in what we are doing in computational design, so you can deconstruct this, and then by deconstructing this, you're gonna get the edges, and then you're going to get the surfaces. And if in this case we have only one surface, so any type of thing, any type of BREP or boundary representation object, so we got the vertices for this, and then we have like the 4 vertices in here, and then I can make a polyline, and then this polyline in here I can use these sorry, this is polygon. So I can use this as the polyline in here, and I can put the vertices back together, and then I need to close this guy off. So now I have the access to this as only one curve in here instead of 4 curves. So now this is a polyline, and this is the collection of the 4 lines. So this is one way also of getting access to this. And then some people may say that I would like to get the scale in here. I can do this also, and then getting a scale, and then getting a geometry, and then where is the center for the scale? I can use this, and I can have this scale surface in here. But the reason that I'm doing this is just like for the further reference that you're using this, you can understand, what's going on, and then you can use this as you need or as you want. So, and then I can use this, or I can say that, let me put these guys up in here. I don't want to see them. So I'm going to scale these guys in here. And what I'm going to do, the same thing that is happening in the scale that I showed you. So I'm using these edges in here, and I'm going to get the area, get the centroid for the center, and then adding a number of, like, for example, 0.70. So you can scale down this guy to 0.70. And also, what else that I can do, actually, because there is always, we have a kind of distance between the surfaces that we have, because this is like a kind of angled sort of surface. Always we have very small sort of fraction that you cannot see it with your eyes, and this is because of the geometrical sort of, just like the I would say detachment or tolerance. So now what we need to do, actually, we're going to project the line, the set of the line that we got to the surface that we have, to make sure that we don't have any distance between the surface and the line that we got from here. So and then that fraction, the number that I'm talking about, is just like probably like digit 6 or digit 5 or something like that. So always we have like these kind of issues in computational work. So project is a very let me project the curve to a birep, not the other one. So this one, you can find this one under curve and under utility. So project the first one is project the curve onto a birep. So what we need to do is just like, this is the surface that we have. This is the birep, is the surface. So birep is boundary representation. So any type of, just like object that is representing any boundary. So it's called birep. So, and then we have the object in a geometry as a curve in here. Now we can turn off the rest of the definition that we don't need it. And then now we have this guy is projected on the surface that we have. So everything until here is ready. So I got this one. This is my, let me do this very quickly for you guys. This is my building surface. So this is building facade, and this is taking the boundary of a facade, or the surface for facade, and this is going to rescale the boundary. So scale down the boundary. So now we have this guy as also projection of the boundary to facade. And everything is good so far, so good. So we are trying to find some points in here to have the point distributed randomly in here to find the location for the fenestration that we would like to add in here. Again, you can use any other method, but I'm using a random one. Is also is really interesting to control the randomness of that. So I'm going to change this boundary actually to a surface because right now is a curve. So now we have like this guy as one boundary, but before that I need to put everything into one. Let me show you. These are 4 branches of data, and then it's different. There are 4 index in one branch. So we have 4 branches of data. So we need to put all of these guys together in one branch. So now we have the surface, and the surface is ready. So let me turn off this guy for now, and then turn on this to show you that this is the boundary representation of the surface that we got in here. So now we have this surface also, and everything is ready for getting a random point cloud. Actually, we would like to use in here. So let me see what we have in here. So the point cloud that we have, the population, the populated, geometry that we got in here. So what we have a very interesting tool is getting a surface or a volume, and the output would be a sets of the random point inside this. And then if you change the number of the seed in here, so you can get the different sort of random sets of the point and the number of the points that you want, and then uh, pretty much that's it. So you can also give it a set of the points that we don't use it in here. So the first thing that I need is the geometry. So the geometry of mine is a surface, and then the count is, I would like to start with something around like 10, and I'm going to use 10 surfaces in 10 points in here. And I'm going to add a seed in here like 100. That's fine. So now if you look at this, these collection of the points in here, if I'm going to change this number, so the number of the points and the count for the points are 10, but the location and distribution are changing based on the shuffle number that we got, and then this guy is distributing them into this path. And then it's really interesting. You can, if you're interested in computational design, it's a very simple sort of component. Even you can write the script for this, and then you can write the same thing in here. You can see. And the other thing that I want actually in here, I would like to have a box to be centered around this guy in here, and then it's going to be part of the fenestration that I want. So what I need to have is getting a box, but we have like different methods for making a box. I'm using a center box in here. So center box is taking the base point or base surface, and then it's asking also for the x and y and z, which is the dimension for the x and y and z for the box. And where you can find this guy, so you can find this under surface, under primitive. So you can get all type of different type of boxes that we can build in here, and then the different sort of methods. So based on 2 points, based on box rectangle, and then other ways. So this is the center box. So what I'm going to do, I'm going to use the population, because these are the population are the points, and I can use the points as the base for the boxes. So as soon as you connect it to this, so all of these boxes are getting connected in here. So, and obviously that we have like a kind of default number in here, default sort of value, and then default value is 1. I'm not going to change that default value, although I'm going to add a slider, and I can change it. That's fine. So this is 1 and 1 and 1. So I can change this and then showing you how it works. So you can get different type of, just like sizes in here. So I think I'm happy with it. So what else that we need is the subtracting this from the surface that we have. We have the split birep. So the splitting is helping us actually to split the I think split, like from Rhino, every one of you guys. But I'm not going to explain this. It's going to be wasting our time. So then we have the birep, which is the object that we have, and then we have the cutters, and then the cutters obviously is the surface that we have at the beginning of the definition. So that is the surface that we have in here. So this is our surface. I can get this and then use this guy as the cutter, and then use the boxes as the surface that I got. So if you see this in here, now you can, I don't know if it's clear in here, but I think I should be clear. So this is the surface that we have, and this is the cutting part. So I'm going to turn off this surface. I don't need this surface anymore. So I want this one, which is the surface, the major surface that I had for my facade and for my building. So now the only thing that I need to do actually is just taking out the part that is in front, or the other one. That doesn't matter. So if I look into the data set that I got in here, so I have like a series of the open direps into different branches, and then each of these guys have like 2 indices. One is 0, 1, 0, and then the other one is 1, which means that we have like one part and then second part. First one and the second one, first one and second one. So if I'm gonna get access to 0 or 1, then everything is gonna be solved. So for doing this, I'm gonna use an item list. So we call an item list to get access to the object within the trees that we have in here. So for doing this, I need a number which is representing and associated with the numbers for the indices that we have in here. So I'm going to use a number 0 by double click on the surface and on the canvas, and then double quotation 0, enter, and then double click again, and then double quotation, and then 1. Just for the sake of having both 0 and 1, I can use a slider too. Doesn't matter. So I'm just like using this as for the sake of clarity for you guys, because most of the time people are changing the sliders without paying attention to them. So I would like to use this to grab the attention of the students into what they're doing and then what they're connecting to. So this is the first step. So this is the list that we have, and this is the list of the object. So now if I use 0, so this is the object that we have on the other side. So if I'm going to use 1, then I'm going to get the object on the other side of the story. So I think that would be interesting. So everything is good. So the other thing that I need to see, because we have like the surfaces and the steel is not open in here, I need to open up this. And then what I need to do, actually, I need to get another box, and this time I'm going to use a box in here with domain box, and I'm going to use the surface that I have in here for the domain box that we have in here. Well, let me do it, just like in a different way. So let me rephrase it. So probably would be easier this way. I'm just like doing a little bit, just like more complex way. So this would be easier, better. So I instead of using a split, this time we're using the split BREP multiple. There is another component under intersect and under shape. So this is like getting the BREP and then getting the cutters in here. And then since we have the surface as the BREP, this time we have the surface as the BREP, not as a cutter. So last time we got the surface as a cutter. This time we got the surface, the facade of our building as the BREP. And then the cutters are the boxes that we have in here. So this is the cutter as the boxes that we got. And then what we need to do, we need to, again, we have like two sets of the surfaces. One is the surface minus these smaller pieces, and then also we're gonna have these smaller pieces all together. So what I'm gonna do again, I'm gonna get see the list, and then what's happening in here. So we can see that we have like 10 um, surface in here, 11 surfaces in here, because it's starting with index 0 and then end up with index 10. So altogether it's going to be 11, and the reason is because I use the count number 10, which means that I'm going to get 10 boxes, and then I have 10 boxes, which means that we're having 10 surfaces in here plus one surface as the major surface minus, and then subtracted from these surfaces subtracted from the major surface. Then we're gonna have like 11 surfaces in here. So based on the definition of Grasshopper, always the very first one is the one that you get from BREP. Then the rest is going to be the cutters one, the cut ones actually. So what I'm going to do, actually, I'm gonna run a test and see if it's going to work. I'm going to copy paste this guy, and I'm going to disconnect this by holding control, and disconnect this by holding control. So I'm going to use this. Now I can have this guy ready for the surface that I have for the cutout surface. So now I'm going to use this, and I think it works perfect. Yeah, that works perfectly. Yeah. So now the only thing that I need to do is just like turning off the rest of the definition. So I don't need the rest of the definition. So, and I can go and merge these guys together. You remember merge, I think. So this is merging the separate geometries. Well, we can also try one more time the solid union. But I think we're gonna have some issue with solid union again in here too. So, but let me. Well, yeah, we have like some issues. So some of the surfaces is just like it's not complete. Yeah. So let me not to use this, and then let me merge this one and then this one. And merging these guys together is giving me the final result of my facade design. And I can bake this, and I can add any detail that I want. And if I would like to see that, you can double check the surfaces in here sometimes, because this is a box and this is inside of the box if you're using it for the visualization purposes. So you need to do the rendering actually with like a kind of double-sided surfaces. And then for doing this, you need to, if you're using, for example, V-Ray, so you need to have your object, and then the object that you have, the material that you have. So let's say I have a material, and then the material that you're using in here, well, you can generate a material in here. So we can go on the material that we would like to use, and then add a bitmap actually, and then go to texture, having a texture in here. So I'm going to use J's displacement. And I can have this in here. Then I can go to the lower side, and then I can say that this is a double-sided sort of, like surface that I have or object that I have, and then you can add this generic material, and then you can rename this. Let's say rename it with the facade tectonics or whatever. So, and I can apply this to selection that you have, and then obviously if we have like the rendering part, so everything is going to be rendered. So give it a few seconds. So now we have this issue. So what else we can do? Let's double check what we can do actually in here. The other thing that you can do is just ungroup this, and you can select all of these guys and then flip them. And then by flipping them, so now you have the surfaces is coming on the other side. Now you see that it's covered. Even double-sided actually is not working sometimes with the rendering engine that you're using. So double-sided. So this is the back side of the surface that we have, and this is the front side of the surface. So I colored it in a way that we can. I always can double check it. And then if you want to see how you can do this, so you can go to the display option, and in display option you can go to shaded mode, and then in the shaded mode go to back face settings, and then you can say that single back face I would like to have like a kind of red or blue. So now if you change it, so everything is going to get blue, so back behind it is blue, the other side is what is it? The grayish type of color. So now I would like to get back to my reddish type of color. So this way I always control that the positive and negative faces for my surfaces. So this is really helpful to understand what's going on with your model, and then you're not going to get super confused about what you're doing later for your purposes for the design part. Let me do the add the label in here to group, and then this is random generating fenestration location. So, and this is the fenestration profile or boxes or whatever. So profile fenestration. And this is the cutting part, and then cutting part, and then I call it final collection. Of facade that we have, and obviously I can delete this. I don't need it anymore. So obviously, what else that I can do? I can change the seed number in here, and then by changing the seed number, this is fully parametric, so it's working with the location of these windows. I can also show my surface. And then because this is again parametric, so I can work with the points and I can change the location of the point. So still, oh, because this is like a kind of it's not on this on the same plane. So we need to just go to the construction plane, put it on the object, then move it around actually rather than the other way. So now we have this guy is fully parametric, is working with the shape that you have. And I can hide this guy again, and I can get back to my original surface. So this is a very interesting sort of facade. And then I can also do some other stuff. So I can decrease the distance between the point cloud with the edge by increasing this scale, so it's going toward more of the outside or getting toward more inside of the facade. And then also I can change the number of the fenestration that I have in here by changing this number and then making it, let's say 20, and then okay, and then the maximum is 20, so I can add a little bit more surfaces in here. Again, the seed can be changed, so I can see that which one is suiting my purpose for what I'm doing. So I'm going to internalize this data, which means that you don't need to have the file for Rhino file. I'm going to delete this for now. So, and I'm going to save this. And under stop AR3 and this is like 6 1st 2020, and then workshop 2. All right. Any question? Anyone?
I tried to do it, but it gave me an error when I tried to add the secondary B-rep split. It's creating duplicate surfaces, but maybe when I look at your script, it'll make more sense.
So could you, yeah, so you have this guy connected to this, right?
Correct.
And then you have this guy connected to this.
Correct.
So here you got the error.
Yeah, it's not giving me an error. It's just saying that it's what do you call it? It's just creating multiple surfaces. You know, there's the artifacting when there's multiple surfaces on a single plane.
Probably because you have multi-surfaces in here. So start with one, use one surface, and then try it with one surface, not multiple surfaces in here. So if you're using more than one surface, probably you're going to get some issues in here. This can be one of the reasons actually.
Okay.
Use only one surface, and then use it in here, and then connect it in here. If you're adding more than one surface, probably you're going to have some issue. You might have some issue.
Okay. Actually, I just flattened it and it worked, so perfect.
Okay.
Thank
So
you.
if you're flattening, I don't know what did you do that you need to flatten, because you don't need to flatten anything but this guy. So
hey, Eric, just a quick question on why exactly did you have to rotate the plane to the C plane? Why did you have to turn the surface for it to work?
So in here, because the surface is, as I said, you know, just like the surface is planar, so we are focusing only on the planar surfaces. We're not going to have any type of, you know, just like curved sort of surfaces or the 4 points of the surface of the 4-point surfaces, all of them should be on one planar.
Oh, that's okay. Yeah, it's yeah. This is a
Otherwise,
plain
yeah.
surface.
Otherwise,
Yeah.
yes. Yeah.
So that could be a really small thing if one of the points is off and it just throws it for a loop, huh?
Yes, because it's more like a kind of construction industry type of thing. So whatever you do actually in construction, even if you have like 4 points not on one single surface, then you're gonna have like some issues with the calculation and everything. So everything is gonna be completely
Yeah.
off actually. So
On construction sites, we just pick up a bigger hammer.
yes. Exactly. So, and then the issue is when you move this point, you don't know how you are connecting these points, and then there is no single, just like because in computer everything is easy, but when you go out, then you move this point, then these are completely, just like distorted sort of, just like surfaces. And then we have like a kind of a strategy for doing this in computational design, which is really interesting, and then you can use it. So we are, by moving this, we have this kind of issues. Well, let's say I have like the show in here, and then let's say I'm going to move this point. Then if I'm going to move this point, then we have like the surface right now is internalized. That's why we don't see any issue. So if I have this, because this is like a kind of completely distorted surface, so what we are going to do actually in any type of, just like industry, I think including construction, so we need to optimize this, and then there is no other way. So we can make this as a rectangular sort of surface, and that is the optimization. So instead of using this surface, we need to have like a crinkled surface, 2 surfaces actually, and then we need to divide it into 2 triangulated sort of surfaces. So that's the only way that we do actually most of the time. If you're having like a panelized sort of surface, so. Yeah. Mm-hmm.
Rationalizing.
Yeah. So that's the. There are only 3 points. There are only if you have only 3 points that you can be sure that there is one surface is going through those 3 points. If you have 4 points, you never know. So more than 3 points, you never know.
Yeah.
So yeah. Anyway, so I'm going to
I have a question.
Sure.
Right now your surface is parallel with the x-axis, and then I noticed the boxes are also aligned like with the axes. But what if you're working what if the surface is at like a 45-degree angle or something? Is there a way to project the boxes onto that surface?
That would be, yes.
Normalization, I guess you would call it.
Yeah, that would be a little bit more complex. So I don't want to explain it in here, but I'm going to give you the definition how to do that, because you need to get the surface, you need to get the plane, and then you need to get the rotation of that surface. So what is that rotation? Then you need to rotate everything on that surface. Then it's going to be a little bit, just like complex for explaining it to you guys. So in my DAF classes, actually it takes around like 1.5 session, so to explain what's going on. So
Okay.
I'm going to put it into the definition to have the boxes sync with the degree of with the rotation of the surface. Then you can use it later. Yeah.
Cool. Thank you.
Cool. So and then let's move to the next part. I think we have like almost half an hour or like 45 minutes. All right, so next part is the definition that I showed you earlier for the random generation of the perforated skin and we're working on this. This is, I think, it's pretty cool, interesting definition. But the randomness in the next assignment, next sort of exercise that we're going to do, it's not the same randomness that I showed you in here. It's a little bit different, but we'll see how it works. Okay, so let me save this and let me open up a new one. Okay. All right. So as a as for a beginning, so I'm going to use the surface again, and I'm going to add this surface. I think by now you should be mastering this. So this is a planar surface as we talked before. So I'm going to have a contour. I'm going to have a contour again. So you remember that we used it before. So under intersect, under mathematical, so you have the contour, and then we're going to have the direction, and then here we can have the direction also as the 3-point vector or three value vector by x and y, and z for making a vector xyz. So this is my surface and this is the vector. So you remember the vector. So I'm using just one because I would like to use it along x. So later you can adjust it with the surface. Again, the same thing that your classmate actually mentioned. So I'm going to use this, and I'm going to use this vector as the direction that I have. So on the x, and the distance is going to be probably 1 would be okay, I think. We can change it later. So these are the points. Yes, I think it's good. So now we have direction in here. So even if you change this, you're not going to have any, you're not going to get anything because this is x, and y and z is going to be 0. So everything is going to be along x. So if you're having other directions, so you need to find the direction of the surface and then you use that. So, and what else? Also, I can put all these contour in one set of the data branch, and then instead of having all of these guys separate from each other, so I can flatten this and then put them into one branch of data. So, and then these are curve. So, and I can use all of these curves in here. And this is interesting to see that one more contour. I'm going to use one more contour in here. So that is the contour. You're going to see the difference for this contour, but this is going to be used actually for these curve rather than the surfaces. So this is going to bear up and then meshes and the surfaces. This is going to curves. So I'm going to use this as the contour line for the curves. I would like to find the points for the location of the fenestration in here, because some people may say that I can use divide. So but divide, I don't like the divide in here, and then it's not working for me. So I would like to divide part. So at the end, we're going to get like different sort of distances. I don't want to have that. So I want to have everything equally distributed evenly. So, and that's why I would like to use this. And I'm going to use another x and y z vector. This time the direction is z for me. So I'm going to use z, and for z, I'm going to add 0, and then by default, x and y is going to be 1. Sorry, it's going to be 0. So, and then we have like 0, 0, 1. So the direction of the vector is going toward the along with the z-axis, and this is the direction. And the point, you don't need to add the point in here. So, and then also as for the distance, because I would like to have a kind of grid in here, I would add the same number at the distance to these guys too. So now, if you can see that we provided a grid of the points in here, there are many different ways of doing this, but this is really interesting and easy to use way for doing this. So the other thing that I need to have, like I need to get this surface closest point. So as I told you that we have always a kind of very small sort of distance between the points and the surface. And then we don't see that distance, but always we are trying to make sure that we're not going to get any sort of issue. So I'm going to use the contour for this guy. Is on their surface, on their analysis, on their surface, on their analysis. And then this is surface closest point. And then also grab this one from the same menu, is evaluate surface. So also use this one too. So for doing this, I need to flatten this because I have like different branches of data. I don't want them, and I want only the points and all of them in one branch of data. And then the surface obviously is the surface that I started from. I departed from, actually, is the surface that I got in here. Now I can make sure that as for the points, everything is on the surface, and then there is no small gap or something between the point and the surface that we have. So, and then the other thing that I need to do is just like getting the normal of these guys, because I need the normal. Normal is the vector is perpendicular to the surface at the point of getting normal. So I'm going to get that by using the surface from the beginning. So I have the surface, and then also I have the point. So in this case, this is not the point. Hey guys, everyone, pay attention that I've seen that almost the majority of people making this mistake. So this is not the point that you would like to use. This is UV point. UV point that you're going to use. And then you got all the planes in here, and this is the plane is on the surface and a perpendicular normal coming out of the surface. So the to make these guys actually smaller, so you can go to display, and then you can go to preview plane size, and then you can make it like change it to 0.1, and then okay. So everything is going to get small, so you don't need to be worried about the size of these guys. Or you can get the normal out of this and then turn off this guy, so you're not going to see the plane sign in here if it's annoying you. So what else that I want to do? I want to make some circles. So I'm using one of these. There are so many different ways actually to draw a circle. One of the way is getting a plane and then getting a radius, and then playing with it, and then just like you can get the circle. So what you are having in here is the plane, and then that plane is not a point anymore. So you don't want to use the point, or you don't want to use the normal. We're going to use the frame. Frame is another name for the planar surfaces that we got laid down on this surface, on the major surface for the facade that we got. So we're going to get the frame in here. And then we have like the circles ready in here. So I would like to add a number slider between 0.01, because I don't want to use 0, because we don't have any circle with the radius of 0. And the maximum that I'm going to use 0.5. I don't know. I think it's going to be okay. So now I'm going to use this, and I can see, oh, they are coming out. So, and I can turn off the rest of the definition in here, and I don't need this. So now I have my points as the fenestrate, or as a kind of a perforated sheet is coming out in here. So what I can do actually is there are a few things that I can do. And one thing is I can get a bear-up edge in here, and getting a bear-up edge, and I can say that this is a edges for this guy. So again, I can get the surface edge or face edge, or I can get the bear-up edge, and then I can also use join. So I can use them join, not join bear-up, so join curves. I'm going to bring up the other one too. So let me show you this. So bear-up edges under surface under analysis. Bear-up edges under surface under analysis, and then also join curves is under curve under utility in here. So this is the second row actually to the right. So and now we can join all these curves. Now they're joined, or if you remember, you can deconstruct it and then you can polyline it from the last one that I explained. And also, what else that I need is a region difference. So it's a region difference. There is another component is called region difference. So you can find it under intersect under shape, under intersect under shape. So region difference. So it's in here. And let's see if it works. I don't know. We have the planar surface. These guys also are planar, so everything is fine. Hopefully everything is going to work. We don't have any sort of tolerance or something. So that's the kind of issues that sometimes we get. So still working. Let's get a few seconds. Hopefully he's not going to crash. I don't know. This seems odd to me, but all right. Meanwhile, it's working. I don't know. I think it's some sort of just like crashing issue. So meanwhile, it works. Do you have any questions or anything that you would like to talk about?
Is there any way you could generate different sizes of holes, like going from or
Yes.
circles? Going from
Yes, that's the next part that I'm just like starting with this, and I'm gonna show you next. Hopefully, this is gonna work. So that's the next part. Yes.
So Eric, right now it's just looking to clip the circles at the edges or eliminate the ones that actually engage the edge.
No, actually, I'm not eliminating them. So it's more of a kind of the same thing that we see, like the punches going even to the edges, and then to the corners, to the edges. So it's more like kind of distribution of the punches, but it's not that hard for well, it's not that easy, to be honest with you. Let's put it this way: it's not that easy for these guys actually to do that. But it's really I'd say probably like pain to to get, because it's easy if they understand the data tree, and then how we have like the intersection. If we have the intersection, we need to call them as the false, true, and false list, and then get the true and false list, and then false, and then drag out the false one, and then use the true one. The true are the ones that they are inside the surface that we have, and then if we have like any sort of intersection, those are gonna be false. So I think it's gonna be too much for doing this, but the principles is easy.
Yeah.
So let me see. I think it's kind of issue that we have. Okay. Oh, you got it.
Well,
So there you go. So let me save this also. So now we have these guys, and the only thing that I need to do is just like getting a boundary surface, and then we can turn off the rest of the definition. So, and then also the first surface that we got. So now we have this, and then obviously if I'm going to change this to 0.1, then we're going to have like a kind of a smaller sort of punches to the surface, and we can calculate that. Hopefully it's not going to take too much time. So we're getting closer to a perforated sort of sheet, and for the design of the facade. So let's move to the next part that your classmate actually asked about. If could we have like different sort of sizes in here? Yes. So there are two ways that I'm regulating and I'm governing these sizes in here. One way is using a random generator for the sizes of the circles that and the punches that we have into this the surface. And the second one is based on what we call an attractor and repeller. So it's a relative distance from that specific point that we have, and then the sizes of these circles is working with that distance. So hopefully this is not gonna. Uh-huh. All right. Okay, let me do one thing. I think that's the issue. So I put the pufferfish in here. So now we got a kind of issue. So with the older version of pufferfish. So where is that? MNOP pufferfish in here. Then this guy is closed. So I'm going to go to the next part. I think this is just like 2 more parts for this, and I'm going to use the last one that I saved somewhere in here. Yeah, I'm happy that I saved it. So ignore recovery file, and I'm going to have the surface in here. So the rest, I think it's good. I wish that I didn't open up this guy in here. Okay, let me close off this, and then I'm gonna work on the definition in a different way, and then make it a little bit, just like less heavy, because this is the calculation for the surface is so huge, because we have the boundaries, and the boundaries is just like always very heavy duty sort of calculation for the computer. So even for this really powerful computer, we have like some issues. So let me open up this, and then let me open up this guy, ignore recovery. Then I'm going to disconnect this for now. And I'm going to disconnect this one also, so you can add later at the boundary yourself. So I'm going to give you the shape, and the later you can add these two. These are really huge actually. From here to here, you need to connect this guy to A and this guy to B. So I'm not going to connect it in here because it takes a lot of time actually, because the number of the points that we have in here is too many. So we have one set. All right. Okay. So the calculation part is on you guys, so you can use the calculation and see what's going to happen. So now I have this surface, and I can hide this, and I can say that this guy should be internalized. And what I'm going to do, I'm going to use this as the first one, as the first definition that we have. And I'm going to copy paste this down in here to work on the second one. Then also let me decrease the number of the contours in here by changing the size of the contours. This way we can get fewer probably circles. Okay. All right, that's good. And then I'm going to turn off these guys. So this was the part that we had. All right. So now we have fewer circle in here. And then obviously, if we, as Philip mentioned that we would like to have like a kind of a smaller sort of surface, yes, we can do this. This is going to be really easy. So in another way, Philip, so that's one of the way is just like calculating this. The other one is just we can have like the scaling of this guy, and then I can get the area, and I can use that area for this surface, and then get the centroid for the center, and then get this guy for the 0.95, let's say, as the scale. And then it's going to be smaller. The area is going to be smaller. But if you were talking about like extracting the ones that they are having some type of, just like intersection, that would be hard for these guys. So if you would like to do something like very probably easier, so I can do it this way. There you go. So now we have this guy, this guy, and this guy. So now we have this guy is being controlled inside this space, and now everything is smaller than the edges, so we're not going to have any contact. So this is the best way for this level to do this kind of, just like avoiding the edges. So let's go to the next part. And for the next part, that what I'm going to do is just like working with the random numbers that we have in here. So what we're going to do in here, so we're using a random generating numbers for the range, based on the range that we got. And you can get this from these sets, and then from the sequences, from the sequence and the set sequence and random. And what I'm going to do, I'm just like trying to change the, I'm going to change the two things. One is getting the point for the contour lines, and then change the getting a random number in a specific domain, and then feed this instead of getting this radius in here. So I don't need this, but I'm going to put it, I'm going to keep it in here for now. And what I'm going to do, I'm going to flatten the tree. So I'm not going to flatten the tree in here because sometimes I need it. I'm going to use another component. It's called flatten tree. Is the same thing that is happening in here. I don't want to use it in here. I want to not to touch this. So flatten tree under sets on the tree. So we have this guy. So, and then I'm going to get the list length. So which means that I need to know how many circles that I have in this surface that I have. Or I can also use the number of the contours, but I would like to use it in here. So I'm going to get the number of the points that I have in here. So under set on the list, so this is giving me the length of the list, which is a number. And in this case, because we have like the number of the contours in here, they have 11 by 11, so 121. So 121 points that I have, and I'm going to have 121 circles. So this is the number of the circles that I have. So this is the first thing. Then I would like to have a range for the different sizes for the radii for the circles. So I'm going to construct a domain. So where you can find a constructed domain under mathematics under domain. So this is giving me the opportunity to define a range between, let's say, 0.1 is the smallest number that I get from the random generating component. And then the biggest number I'm going to use is 0.2, let's say, for example. I don't know. It's something like this, but I can change it. What I have in here, 0.34. So let's say 0.34. So 0.34. And I'm going to use the same number. So this is the maximum and this is the minimum. So minimum and the maximum. So this is the range. And the range is going to this. And then I can use a seed in here. So if I look into the data set that I have in here, so I'm going to have 121, which is the indices from 0 to 120. So 120. So 120 and then 0 is the beginning. So these are the random numbers between 0.01 and then 0.034. So, and then if I'm going to change this, so everything is going to change, right? And then if I'm going to add a seed in here and then I change the seed is giving me different random numbers. So now is the time to delete this slider. And then by default, that's why you get the radii for the circles. That by default is 1. So I'm going to use these numbers as for 121 circles that I have. Now I have everything ready in here, and I can say that I can turn these guys off, and I can decrease the maximum, or even I can decrease the minimum, and I can say, you know, just like instead of 0.01, so I would like to have like a kind of minimum a little bit bigger. So now we have this guy, and then we have this guy. So, and obviously we scale it down. So this is going to be our surface, and this is going to be turned off. And then obviously, if I would like to get this one going correctly, so I need to get the surface from this. There you go. And then this one, and this one, and this one is ready. So now I can say that if I would like to show the surface, and then assign this surface again one more time because I internalized that. So, and then this is parametrically working, and I can say that. So, what is the issue? Oh, we have like always some issues. There you go. So now this one, because I internalized this and then I use it again, I don't know. It's just like probably sometimes it's having some issues. So if I'm going to change this, so now you can see that the points are working perfectly. And then the good thing is I don't need to control the number of the circles in here because it's parametrically done. So this time I don't know how many points that I have, 166. So if I'm going to change this and I'm going to move this, it's going to be 211. If I'm going to move it back, move it down to the smaller sort of size, and then this is going to be 60 points and 60 surfaces, and I can make it smaller. Or if I'm going to change this number for the distance a little bit smaller, so I'm going to have like more surfaces in here. And if I'm going to see this, I don't want to make this computer actually crash again, because it takes a little bit of time to get solved. Oh, by the way, if you're going to change this number, So you can see that the distribution is changing. And then let me save this before I'm going to do this. And I'm going to put this guy down in here so you can connect it later. So save this one more time, and I'm going to have this guy, and I'm going to have this guy. Hopefully it's going to work this time.
What was that node that you just connected it to? Or
Which one?
sorry, the A and B.
The A and B is region difference.
Region difference. Thank you.
No problem. So, and now is working. So I drag down the number of these points now of the circles. I think is working. And then Philip, so we don't have any sort of, just like the condition sort of edges, but I really like the condition edges, edge condition, sorry, that we see, for example, in here, but I don't know. It's just like, this is the kind of thing that it's happening a lot in the perforated sort of sheet, but it's up to you. And then if you like to ask them,
I think that's a really good point. I think it's probably a discussion that is sort of separate of this, and it relates to the actual fabrication, right?
Yes.
Like if you join panel to panel,
yep,
and the continuation of a pattern, right? So
right.
In the studio's application, we're not concerned about that. It's primarily a image making or developing a logic for a facade.
Yeah.
Yeah.
Well, I wrote something actually for I don't know who was that, for Carrie Johnson. So something that's just like a kind of distribution of the pattern, and then also for it's more complex than this, but it's the same sort of principle. And then you can see a kind of pattern through the entire, just like surface. But it's, I think it's UCSD, one of the UCSD project or whatever college that they worked on, and it's just like a kind of a skin facade that they did. So I did something for them. So pardon me, what is it?
Oh, nothing. That sounds good.
Oh, no.
Right? Like it's the fabrication of like how to break the sheet metal with the flaps, right? And how it's connected and all that. So
yeah, exactly. And we have IV actually. So if someone is interested, so we have IV. So IV is giving you all the flaps and everything by calculating the algorithm and everything, so you can get the flaps. So and then even just like the flaps that you need, so you can get everything for your construction work, and then for the fabrication part. So let me finish this with one more part for this definition, and then I'm going to use again the exact same thing. Let me disable this. This way, use less power actually. So I'm going to use the same definition and copy paste it down in here. So what I'm going to do, I'm going to go and then enable this part. And then we have these guys. All right. Okay, I'm going to disconnect this. Oh, by the way, I forgot to mention something that probably people like some people think that they don't want to see the icon for every component, but I think it's really interesting mistake. So because some of the components, they have like errors with the text, and then because it looks like a little bit probably more professional, they would like to use the text, but the text have like some clashes with the program inside, and that is coming from the object-oriented programming, and then they have like some messed up sort of name. That's why I don't want to use the text. So it has like I have seen at least 4 or 5 different components. They have like some clashes when you use them with the text. So, but it's up to you if you want to do that. If you've seen around, so it's not my my call. So it's yours. So let's do this, and then let's move to the next part, the last part of this assignment in this exercise. Actually, sorry. And then what we're going to do in here. Let me see. Yeah, I think we can do it in different ways, but I'm going to use this scale this time. We're going to have like this guy. We did this one. This is like a random generated sort of, just like the radii for the circles. This time is a rule based, and which means that we have a kind of concentration of the smaller the circles with the smaller sort of radii in here. And then when you go away from this point, then we're gonna have like a kind of bigger sort of circles, or the other way, so bigger with going to the smaller, or even we can have some sort of pattern and then following those kind of patterns. So now we call them attractors and repellers. So it's a huge concept actually in computational design. So there is a sort of rule based, which means that you have a rule, and then based on that rule, so you're trying to govern some of your geometries. So in here, I'm going to let me see what would be the best way for doing this. So let me disconnect this, and I'm going to delete this part, and I'm going to keep this for now. I'm going to tell you why later. So I'm going to keep this part, and I'm going to have the circles something like 0.10, probably. I don't know. Yeah, probably 0.10 for now. And I'm going to turn this guy on, so everything is the same size. We did it before. I'm going to disconnect this by holding Control. And what I'm going to do, I'm going to scale all of these circles based on the rule that I'm going to define in here. So what would be that rule? So I'm going to tell you in a second. So let me start with this. So this is my circle. Series of the circle. This is the frame, is the center. I'm going to use the frame as the center, because if you remember that we had the frame and then a location, and then I'm going to use this for the center. Then I'm going to turn off this guy again. Now we have the scale down the circles that we have, and then we got this scale down by half, but we don't want to do this. So you want to have like a kind of rule in here, and that rule is going to defining a point in here. I'm going to define a point. Let's go to the front view. So I'm going to define a point in here, and I'm going saying that if I have the smaller distance, then we're going to have a smaller radii. If I'm going to have the bigger distance, then I'm going to have like a bigger sort of radii for the what is it, the circles that we have. So how we're going to do this, so we have a point in here, so I'm going to use as a point container. So if you go to Pram, if you go to geometry, you go to point, so you grab a point component for yourself. So and then assign this point to this. So this is now it's in Grasshopper. So I'm gonna get I'm gonna assess and calculate the distance between all these points that we have in here, and then this point that I generated as the location of the force of a central or point base sort of force. And I'm going to evaluate that distance from all these points to this. And I'm getting a series of the distances, a series of numbers. So now these numbers can be used because now we have like different sort of, let's say I have this point, and then we have these points. Now I have the number, and then this is showing me the distance because A is smaller than B, and then I have the list of them. Now I can use A for manipulating the size of the circle in here, the size of the radius of the circle in here, comparing to the B, and then B is bigger. Now I can have like a bigger one. But how? Because these are like a kind of huge numbers if I'm going to add to the factor. So we're going to have like a kind of very big numbers. So I don't want to do this. So this is the remapping the information. So remapping the information is one of the hugest ever thing, actually, I think, invention of human being. So I really like the remapping the information. So we have a bound in here. So we have the upper bound and lower bound of the information of the data that we got in here. So which means that whatever we got in here is the domain between 3.2 is the lowest number, and then 21.5 is the biggest number that we got in here. And what we're having is a remap numbers component. So you get the bounds, sorry, you got the bounds under mathematics and under domain in here, bounds. And then also from the same menu, you're going to get the remap numbers. So we have the remap numbers in here. So now we have the remapping of the values that we got. These are the values. So this is the values. And then this is the source. This is the source domain, which means that this is between 3.2 and then 21 something. So now we have this one. What is the target? So I would like to do something to these scale of the radii of the circles that we have in here. So, and then by changing the circles, then we're going to have like a kind of pattern of the things. So of the circles. So I'm going to use again one more time this guy, and I'm going to use a domain that is a new domain. So this is the old domain. Let's see that this way. So this is the old domain, and this is the new domain that I have. So which means that is finding Grasshopper is finding the corresponding number by putting the first number is 0.15 equal to 3.2, and the last number is 0.5 equal to 21, and then find all the numbers between these guys coming from this list, and then give me a new list. So I'm going to make this a little bit bigger, probably, let's say like something like 0.8. I don't know. Let's say 0.8, and I think this guy can be something around like 2-ish, 1.8 or something like that. So now I'm going to get the remapped data, everything between 0.80, I think you can find it somewhere in the list. And then the biggest, this is 0.80. So number 59 is 0.80, which means that if I'm going to get this list in here, so number 59 should be the lowest bound of the same domain that we got. So number 59 is 3.2. As you remember that we had 3.2. So now the old 3.2 is the new 0.8, and the bigger one and the largest, the upper bound, is 1.8. So I'm going to use this for the factor that we got in here, but I'm going to turn off the circles that I don't need to use them. So map them, and then now everything is reacting to the size of this, and I'm going to change this probably a little bit bigger. I don't know. Now everything is reacting to this point. Look at this point. So I'm going to move this point, and I'm going to move it to the other side. So if you can see that, let me see. This is not the right. So I don't want to make, yep. Okay, so now we have everything is reacting to this. Look at this. So this guy is, when we move things, and then circle is closer to this. So they have like a smaller radii, and then far away from this, they have like a kind of bigger radii. So now we have, again, we move this guy. All right. So now we have the effect. In here, and if I would like to be more accurate, I can say that also, again, the same thing is being applied to this, and then we're gonna have like 4 more points. And then as you see that when I stretch the surface to the left, so these bigger size is going toward this, and then this part is not going to change. If I'm going to stretch the other side also away, then again in the middle we're going to have like a kind of a smaller circles, and then on the right hand side and left hand side we have like a bigger one. So I can switch these two numbers if I want, and then I can get the reverse. So in the middle, closer to the point, we have like a kind of bigger circles, and then to the sides, we're gonna have like a smaller circles. So, and I'm going to add this also to the group that we have in here, and I'm going to do one quick thing again, and that would be just like making this a little bit smaller, to not to have like too many points in here. And I'm going to switch back these guys to what we had before. And I'm going to connect this. Oh, I needed to save it before I doing this, but I didn't. That's fine. So sometimes this get minimized automatically. It's not a kind of issue, so you can minimize your Rhino and then you can get it back again. So now I have this one and I have this one. That is perfectly, I think everything is good. Yep. So perfectly working, and I can bake this.
Hey,
Yeah.
Eric, so a quick question.
Sure.
Would this script work with multiple points
Yep.
or attractors?
Yep, but not. I can adjust this, but this is another topic for attractors and repellers. You need to define a relationship between more than one point, so how you're looking at it, because otherwise you're not going to be able to define which point is the smaller one. But you can say that if the sum of the distances that we got from different points, then it's defining the number. Yes, it works that way. Yes.
Okay. Thanks.
So that's one of the thing. That the other thing is also we can add the sort of shape, and then following the shape, not only the point, also the shape or geometry or curve, and then closer to the geometry, then smaller, and then away from geometry, bigger, or vice versa. So, and then also, what else? Let me get rid of this, and then let me see this, and then turn off this guy. I think we have two surfaces. Let me hide this. Yep. So if you have any sort of question that I can answer in here. So one of the thing is the definition that we write in here, always if you are changing or if you're demanding more, you need to adjust some of those guys. That's why I always suggest to practice more and then learn more, because some of the things that we're talking about in here, it takes a lot of time to explain what's going on. I know there are so many question marks for the people you're here that they are not familiar with the scripting, with the visual scripting, and in computational design. But there are so many interesting things is happening inside these components, and then how they are coming out, and how we're using them, how we can put them together. And then I recommend everyone to do more research rather than just like only um, seeing the I don't know videos and then following them. You need to understand what's going on. But for now, because of the limitation of time, and consider this as a kind of intro to the very small possibility of working of computational design. And then if you would like to pursue, yes, you can go ahead, and then you can do more. I'm guessing that Brandon is in here. Brandon is in here. So I didn't know that Brandon is in third year. I thought always Brandon is fourth year. So Brandon is.
Yeah, I'm here.
Hi, Brandon. So I think you can ask him about the possibilities. Also, he's taking the DAF classes about the things that they're doing. They're very complex things. And if you have any question, I'm here. I think we have like few more minutes, and then if not, it's up to your professor. So if you would like to have like Friday, also we can have like Friday, like a kind of shorter sort of session for Q&A, and then other things. And then even Philip, even I can talk about some of the things. For example, you said that could we add another point? Yes, I can bring it up. Could we add, for example, let's say minimum and maximum to this? Let's say instead of just like having everything evenly distributed, let's say we have like the minimum, and then we have the maximum, and then after that maximum nothing is going to change, and then everything is going to be the same. So you have like more of a kind of focused, concentrated part of the points in the middle, and the rest are going to be the same sort of numbers, instead of distribution going evenly all the way to the corner of the surface. So we can bring up more of these kind of very interesting, just like definitions, if you want. If you want, also I can work another on another definition, which is like the movable panels. So, and also I can work on the animated aperture. These are the kind of things that we can do for your class. So if it's your discretion.
Yeah. So first of all, thanks so much for another mind-blowing 2 hours. I've been joking with the students too. We can rewatch the video at half speed, so to kind of keep up. So it's great. Perhaps we talk about the content of the Friday session offline to figure out exactly how, and I can pick up some of the feedback that we're getting between now and Wednesday to again take advantage of your available time. But on behalf of the whole studio, I want to just thank you for popping in and exposing us to this. It's been great. So,
Anytime. My pleasure is working with you, Philip. So we have been working for a long time together. So I think it's a pleasure, and I think I would say I'm honored to be on board.
Thanks so much, Eric. So and yeah, so we'll chat offline, and we'll go from there. Cool.
Perfect. All right. Take care.
See ya.
Thank you, Eric.
Okay.
Bye-bye.
All right. Everyone's still there. I'm gonna stop the recording for now. I'd say it's probably time for all of us to get a break real quick, and we'll reconvene. Let's say in 20 minutes, 6:20, and we'll continue with the rest of the studio. See you then.